Good morning everyone. Today I want to present my assignment with the title of AC Variable Frequency Drive for 3-phase induction motor. My name is LIM CHIN SING. Matrix number is 184127. First of all, the power electronic devices are many applicable in industrial process of our daily life. This induction motor is the muscle to drive this process. So, power electronic device to control the speed of induction motor is very essential. This device is my title, AC Variable Frequency Drive, VFD. So, first of all, what is AC Variable Frequency Drive? It is a power electronic device to control the speed of induction motor by varying the frequency of AC supply to the motor. Basically, this VFD contains 3 sections, which is rectifications, Stage 2, filtering and smoothing, and the last stage is the inverter. This is the diagram of the VFD where the 3 section is controlled by the control unit. There are 3 common type of VFD. The first one, current source inverter VFD, CSI. Second one, voltage source inverter VFD, VSI. And the last one, pulse width modulation VFD, PWM. The difference between them is the intermediate DC circuit used and the inverter circuit. The most commonly used VFD is the PWM VFD. That's why I will focus on the explanation of PWM VFD. This is the diagram of the variable type of variable frequency drive. First one CSI, second one VSI, and the last one is the PWM VFD. So now let me explain to you that the operation of PWM VFD. The first stage is the rectification stage, which is using the 3-phase bridge rectifier. Basically, this bridge rectifier is to rectify the 3-phase AC voltage supplies to DC voltage with 6 pulse ripple of each cycles. This 3-phase bridge rectifier have similar operations to the single-phase full wave rectifier, which is to rectify the AC voltage to DC voltage using the sequence of conducting of these 6 diodes. The sequence of conducting is D1, D2, D3, D2, D3, D4, D5, D4, and D5, D6. So this diagram, from time T0 to T, there are 6 ripples formed from the 3-phase AC voltage input. Then these ripples, this DC voltage, will now channel into the second stage, filtering and smoothing, by the LC filter. So this LC filter will smoothen the output ripple voltage to become nearly straight line DC voltage. By the inductor L will allow the DC to pass but restrict the flow of the AC component. That means the reactive component of the voltage will be cancelled. Thus, only part of the voltage is outputted, which is causes its amplitude is lower than the input. Then this smooth DC voltage is now channeled into the last stages, which is the inverter stages, to convert the DC voltage to AC voltage with another frequency. This is the diagram of the inverter to control the output modulations. The frequency of output signal can be altered by controlling the switching sequence of the inverter transistor IGBT A, B, and C. The voltage is positive in up position and 0 in down positions. So during time period A, G, I, M, O, and U, which is labeled by the blue shaded color, both switches A and B are in down position. Since both lines are same grounded, the line voltage VAB is now 0. Then during time period B, D, F, H, and Z, switch A is up and B is down. Output A is positive respect to B now. Thus, the result line voltage VAB become positive. Then, during time period C, E, K, Q, and S, both switches A and B are up because both are positive terminal. line voltage VAB now becomes 0. Then during period L, N, P, R, and T, switch A is down but B is up. So the output B is more positive than A. Thus, line voltage VAB is now negative. So this switching sequence of the inverter will form a voltage pattern that consists of 5 pulses during each alternation. The dashed line is the sinusoidal wave formed from this 5 pulse waveform. The number of the pulses is adjusted to achieve different output frequency. So, for example, the inverter switching sequence that on-off becomes slower will produce only 1 pulse during each alteration. This diagram shows that with the 1 pulse during each alternations will cause us a output signal with higher frequency, which is shown by the dashed line also. Therefore, these 3 combined sections of power electronic device will form a daily life applicable device, which is AC variable frequency drive, to control the speed of induction motor used in industrial process. So in conclusion, this AC VFD plays a very important role in many industrial or daily life applications, such as elevators, pump and compressor, conveyor belt, and electronic vehicles. This is all for me. Thank you.